All right, Module 15, exponential relationships. We're going to talk about geometric sequences today. And if you remember from a few months ago, we spoke about arithmetic sequences, like 7, 10, 13, 16, 19, ... This is an arithmetic sequence because it has what we call a common difference, meaning if you take a term and subtract it by the previous term, 10 minus 7 would be 3. That difference is common, it's the same throughout the sequence, meaning we always add 3 to get to the next term, and that's why it's arithmetic. It has that constant change, that common difference. And we discussed how to write the explicit and recursive rules of arithmetic sequences as well. Today we're going to look at geometric sequences and how they differ from arithmetic sequences, and also how to write the explicit and recursive rules for geometric sequences. Make sure you take good notes. Let's go. So if you remember with arithmetic sequences, an arithmetic sequence is a sequence of numbers in which the difference remains common. There was a common difference. Okay, that means if you take one term and subtract it by the previous term, it's going to be the same as if you go further down that sequence and take another term and subtract it from the previous term. That was our common difference. With geometric sequences, we're going to have what we call a common ratio. It's a sequence of numbers in which the ratio remains constant. That means if you take 32 and divide it by 16, you get 2. If you take 16 and divide it by 8, you get 2. So if you get 8 and you divide it by 4, you get 2. Every time you're going to have that common ratio that's the same. Which, if we look at this going forward, to get from 2 to the next term, you would need to multiply by 2. And that gives you 4. From 4 to the next term, you would need to multiply by 2. From 32 to get to the next term, you would need to multiply by 2, which would give you 64. We call that our common ratio. Our common ratio is found by dividing each term by its previous term. Okay? And very similar to our common difference, except common difference, we were subtracting by the previous term. This time we are dividing by the previous term, and that'll give us our common ratio. Make sure you write that down. So for these examples, we are going to identify whether this sequence in fact represents a geometric sequence, and if so, we're going to identify the common ratio. So if we look at this, 10 divided by 2 is 5, meaning 2 times 5 would get us to 10. 50 divided by 10 is also 5. 250 divided by 50 is also 5. That means that we are in fact multiplying by 5 every time to get to our next term of this sequence. So this is in fact a geometric sequence, and the common ratio is going to be 5. Okay, now is this a geometric sequence? Well, if we take 45 and we divide it by 135, you're going to get a decimal, and that decimal, if you change it back to a fraction, it would be 1/3. You take 15 and you divide it by 45, you would get 1/3. You get 5 and you divide it by 15, you get 1/3. So we do have a common ratio. The common ratio is 1/3, meaning 135 times 1/3 would get you 45. Or another way of thinking of it, 135 divided by 3 is going to get you 45. 45 times 1/3, or 45 divided by 3, is going to get you to 15. 15 times 1/3, or 15 divided by 3, is going to get you to 5. So yes, this is a geometric sequence, and when it goes down like this, it usually means that we're multiplying by a fraction. So your common ratio is going to be a fraction, which is 1/3. All right, negative 14 divided by 7 is negative 2. 28 divided by negative 14 is negative 2. Negative 56 divided by 28 is negative 2. So is this a geometric sequence? Yes. Your common ratio is negative 2. 7 times negative 2 is negative 14. Negative 14 times negative 2 is positive 28. Okay, so when you see these sequences where where you're going from positive to negative, that usually means that your common ratio is going to, in fact, be a negative number. And that's all. That was all three of our examples. All three of them were geometric sequences. Okay, so now we are given a geometric sequence and we are asked to find the next three terms. So if we take a look at this first one, negative 21 divided by 7 is negative 3, meaning our common ratio is negative 3. We're multiplying by negative 3 every time. It should be negative 3. So to get from this term to the next one, you'd have to multiply by negative 3. And 63 times negative 3 is negative 189. Then you would have to multiply by negative 3 again. So times negative 3 to get from here to here. And negative 189 times negative 3 is positive 567. That should be a negative 3. Then you would have to multiply by negative 3 again to get to that last term. And positive 567 times negative 3 is negative 1,701. For number 9, our numbers are going down, meaning it's going to be a fraction. Well, 4 divided by 8 is 0.5, or 1/2. So that means we are multiplying by 1/2 every time. To get from 8 to 4, we multiply by 1/2. To get from 4 to 2, you multiply by 1/2. All right, then you'd continue to multiply by 1/2. So your next term would be 2 times 1/2, which is 1. And then 1 times 1/2, which is going to be 1/2. And then 1/2 times 1/2, which is going to be 1/4. Those would be your next three terms of that sequence. And last, we could see that we're going from positive to negative, so your common ratio is going to be a negative number. In this case, it's going to be negative 2. We're multiplying by negative 2 every time, right? So to get to the next term, you'd have to multiply negative 56 by negative 2, which is going to be positive 112. Then you would need to multiply that by negative 2, which is going to be negative 224. Then you would need to multiply that by negative 2, which is going to be positive 448. Pause this slide and write all these down. So arithmetic and recursive, let's just say explicit and recursive. To write a geometric sequence in explicit form, and these words should be familiar from when we were discussing arithmetic sequences. Remember, recursives are the ones that you need that previous term in order to get to the next term. That f of n minus 1 means previous term, if you remember that from when we were doing arithmetic. But let's start with explicit. For explicit, it's going to be, and we're using f, not a, sorry about that. F of 1, which f of 1 stands for your first term, just like with arithmetic sequences, times r, and that's the only difference. Instead of d, we're going to, well, not the only difference, but one of the differences. Instead of d, we're going to have an r here, and r stands for your common ratio. And then that's going to be raised to the n minus 1 power. And that's kind of difficult to see here, but that's actually an exponent. We're raising it to the n minus 1 power. Okay, so it's f of n equals your first term, f of 1 times r raised to the n minus 1 power. Now here's if you want to do it with the 0 term, but primarily in class we're going to do it with the first term. And then recursive is f of n minus 1, which f of n minus 1 means previous term, times your common ratio. Now, the recursive rule for arithmetic sequence is very similar, except if instead of multiplication it was addition, and instead of r you had the d there. So go ahead and write this down. We're going to use them in just a moment. Write the rule for the nth term, then find f of 7. So it doesn't specifically say to do it in explicit or recursive, so we'll do it in both. For explicit, actually, number 11 we'll do explicit. So for explicit, remember it's f of n equals your first term times your common ratio raised to the n minus 1 power. So you need your first term, which in this case is 3, and you need your common ratio. It looks like we are 9 divided by 3 is 3, so we're multiplying by 3 every time. So if you plug all that in, that's going to be your first term, which is, it's going to be f of n equals your first term, which is 3, times your common ratio, which is also 3 in this case, raised to the n minus 1 power. Now, what are we plugging in for n? It says to find f of 7, so we're plugging in 7 for n. So it's f of 7 equals 3 times 3 raised to the n minus 1 power. So that's going to be oh, I'm sorry, instead of n, it should have been raised to the 7 minus 1 power. We're plugging in 7. So that's going to be f of 7 equals 3 times 3 raised to the 6th power. Well, 3 raised to the 6th power is 729, and then 729 times 3 is going to be 2,187. All right. Now, 13, your your explicit formula is going to be f of n equals f of 1 times your common ratio raised to the n minus 1 power. So in this case, our first term is 400, and our common ratio is 1/2. So this is going to be f of n, I'll do it down here, f of n equals your first term, which is 400, times your common ratio 1/2 raised to the n minus 1 power. Now we are plugging in 7, so it's going to be f of 7 equals 400 times 1/2 raised to the 7 minus 1 power, raised to the 6th power. You would just put that in your calculator. And if you do that, you would get 6 1/4. And then quickly we'll do one with recursive. So here, if we take 12 and divide it by 8, we figure that our common ratio, this is actually going to be a mixed number or an improper fraction, 3/2 or 1 1/2, whatever way you want to write it. So for recursive, that's going to be f of n equals f of n minus 1, which stands for previous term, times your common ratio. So we already have f of 1, which is 8. We have f of 2, which is 12. We have f of 3, which is 18. So to find f of 4, well, that's going to be f of 4 equals your previous term, your previous answer. So if we're doing f of 4, f of 3 would be the previous answer, which would be, or the previous term, and the answer to that would be 18, times your common ratio, which is 3/2. And if you multiply 18 times 3/2, you get 27. Okay, then to find the fifth term, f of 5, that would be your previous answer, which was 27, times 3/2. And if you do that, you get your answer, which is 40.5. And then to find f of 6, you would just use your previous term, which is 40.5, and multiply it by 3/2. And if you do that, you get 60.75. And last, f of 7, you would have to get your previous term, which was 60.75, and multiply it by 3/2. And if you do that, you get your final answer, which is 91.125. And if you use your explicit formula, you'll find that you'll get the same answer either way. This video is already very long, so we'll save these last two problems for tomorrow. But make sure you have all of these notes. I'm going to specifically look for those explicit and recursive rules for geometric sequences. And I will see you tomorrow. Have a great day.